homework today, I want you to take a look at these vocab words and take a look at these pictures and see if you can match the picture to the appropriate vocab word. We're recalling on things we've already learned, or we're maybe using context clues to match some that we have not yet learned. So if we look at these and we're trying to match them, we have supplementary angles, which are angles that add up to 180. We figured that out in the Kahoot, right? An acute angle, an angle that measures less than 90 degrees. Vertical angles you might not have learned yet, so we are going to talk about that in our vocab. Vertical angles are the opposite angles formed when two lines cross. Angle bisector. Now, bisector is not a new word. An angle is not a new word, but you might not have put them together before. So a bisector is a ray that cuts an angle in half. Bisect, cut in half. So that's what this picture is trying to show right here, is an angle being cut in half by that dotted line. The dotted line would be the bisector. Complementary angles, angles that add up to 90 degrees. Oops, that's a B, I was about to write 90. And of course an obtuse angle. This one isn't very obtuse, but it is above 90 degrees, greater than 90, and so we call it obtuse. Okay. Here are the answers to your vocab sheet. I wanted you to fill that out, you and Google last night, so that you would have to read the definitions and decide what you thought the word was. Read the next definition, decide what you thought the word is. Check your answers, or write them for the first time, and make sure that you are getting to know this vocab, because we will have a quiz next week over vocabulary. Okay, so make sure you have all 12 words written down on your notes page that was provided to you so that you can begin studying and getting to know these words really well. Okay? Now I want you to flip your notes over and go to the back bottom of your notes. There's some white space under there. So flip your notes over and go to the bottom of the back. We're going to talk about what an angle is, since this is the angles unit, and we're going to talk about how to name an angle, the notation that we use. So on the back bottom of your notes, go ahead and draw this angle exactly as you see it. Vocab word number 1 on your sheet is angle. It says an angle is a figure formed by two rays that have the same endpoint. So an angle is a figure made up of two rays with the same endpoint. We'll talk about, I had something else I wanted to say, but we'll talk about that later. So if we look at this angle right here, what rays are making up this angle? We have ray YX and ray YZ. And we notice that both of those rays start with a Y, therefore they have a common endpoint. Okay? We're going to talk about 4 ways we can name this angle, and I want you to write all 4 ways down on the back bottom of your sheet. Okay? Okay. So, way number 1, we could name it using this number right here. We could call it angle 1. You can't just call it 1. You do need to include the angle symbol. Angle 1. Another thing that we could call this angle is angle Y. Now there's 3 letters on there. Why did I pick Y as the name? So someone said because it's the common endpoint. That's really good. You're using your definition. What that common endpoint is called a vertex. So I'm allowed to name this angle in this picture using its vertex. Angle Y. Am I using capital or lowercase? These should all be capitals. These are points. Y is a point, so we're using capital letters. All right, another way I can name it is angle X, Y, Z. And the last way I can name it is angle Z, Y, X. That is using 3 letters. So you can use 1 letter or you can use 3 letters. You cannot name an angle using 2 letters. Don't try that. Don't try that at home, kids. What do you notice about the order of these letters on 3 and 4? Good. Asha had the answer ready to go. Y has to, must be the middle letter because the vertex needs to be named second or in the middle. Okay? So the common thread is that the vertex is in the middle. Okay, so let's look at this example right here. We have a picture that involves more than one angle now. Let's name angle 2 in as many ways possible. What's another name for angle 2? Good. Angle BEA. Angle, what else? Good. Angle AEB, what else? Okay, let's look at the picture. So, if I'm naming it BEA, that means I start at B, I travel to E, and then I end up at A. That is this angle right here. I could even shade it in. This is the interior of the angle. That is angle 2. I could name it AEB. Start at A, go to E, and end at B. That is also angle 2. What I can't name it is angle E. Let's talk about that. On the other slide, I named it angle Y, right? So why can't I name it angle E? Very good. Because in my picture now, unlike the other picture, there's more than one. E is a vertex for more than one angle. E is a vertex for this angle, and this angle, and this angle, and this straight angle. It's also a vertex for this angle. So it's a vertex for like 8 different angles. So I'm not being specific enough. That's like a student calling me Miss. Hey, Miss, what did we do yesterday? Well, Miss is not my name. You're not being specific because my name is Mrs. Tanton. Now, you can call me Mrs. Tanton, or my daughters call me Mommy, or my colleagues call me Amanda. That's 3 ways you could name me, but Miss is not specific enough. So angle E would not work because there's more than one angle there. Okay, now let's answer this one. What is another name for angle CED? When you're given a picture with multiple angles in it, and I name an angle with 3 letters, you need to be able to find that angle quickly. You need to know what angle I'm talking about. Good. CED, you start at C, you travel to E, you stop, and then you travel to D. So I could name it angle 4, or I could name it angle December. Okay, I think we're good on naming angles. Let's move on. Okay, so back to like elementary probably. I'm guessing you learned this in elementary school. I don't know. Classifying angles. Classify means to sort, to group, right? So an acute angle, that's the acute angles. They're little, they're tiny. They're, of course, less than 90 degrees. Then we have our right angles. Think of it as you're standing up straight. You're sitting upright. You're sitting exactly at a 90-degree angle. So our right angle, of course, measures exactly 90 and nothing else. Right angles are formed by perpendicular lines, and we have that in the Kahoot today. An obtuse angle. Think of it as large, obtuse. An obtuse angle is going to be greater than 90. Greater than 90. But I do want to put the disclaimer that it is going to be less than 180. Because if you go past 180, you are now a reflex angle. And we're actually not going to study reflex angles in class. So let me write that a different way. It's going to be greater than 90, but it's going to be less than 180. So I'm going to write where angle X is an obtuse angle between 90 and 180. And then what we call an angle that has, and there's a vertex here, what we call an angle that has 180 degrees exactly is called a straight angle. Good. So remember, we're not going to go past 180. It's called a reflex angle, but that's not on your vocab sheet. Okay, just follow along with me and watch. You do not need to do this in your notes. You don't need to put it anywhere. All right, we're gonna look at angles in a different light now. It says consider ray BE. Okay, Ms. Stanton already plotted it. With B at 0, 0 and E at 5, 0. What transformations to ray BE would result in a straight angle? What do you think? Reflection, Toby. What would we reflect over? Because we have to be specific. Good. A reflection over the y-axis, here to here, would result in a straight angle. Love that answer. What's another answer? Let's talk about the transformations. There's 4. Translate, which means slide. Reflect, which means flip. Rotate, which means turn. And dilate, which you won't need to do here. No dilating. Good. You could perform a rotation. And of course, how many degrees? Well, you're going to rotate 180 degrees. So I want you to think of angles as a ray. From now on, an angle is a ray that has been rotated a certain number of degrees. Think of it as a rotation opening up and creating that angle, a rotation of a ray. Okay, let's look at this one. What transformation to ray DE would result in a right angle? Now, of course, you could rotate 90 degrees. That one's the easy one. I want to know if someone could tell me how to get a right angle by reflecting. Who could get me a right angle using reflection? If we're going to reflect this, you have to be able to name the line of reflection. It's not the x-axis. It's not the y-axis. Alex, good job! Oh my goodness, I love it. You are going to reflect over the line. That's the parent function. Y equals x. If I take this and I reflect over that line, believe it or not, I wish I had Geometry Sketchpad open, it would land right there. It's a reflection over that diagonal line. So it goes from horizontal to, boom, vertical. From horizontal to vertical. Okay, we're going to move on. Get it? A protractor. So it's a protractor turned into a tractor. Okay, let's remind ourselves how to use a protractor. So, in order to use one, you want to make sure that you put this vertical line that you see right here, that goes directly on the vertex. Now, some protractors rest on top of the bottom of the angle, on top of the ray, and some protractors rest like they're clear and you kind of put it through the middle like this one. When you're reading a protractor, you start at 0. A lot of students are like, which set of numbers do I choose? I forgot. Well, first of all, this is an acute angle. So you're going to choose a set of numbers that are acute, that are less than 90. But another way is you do start at that 0, and then you go 10, 20, 30, 40, and I'm a little bit past 45. So it might be around 47 degrees. So you need to align your protractor with the vertex first, and then begin reading from 0 and rotate around until you get to that angle. Now, I have seen students do this. The angles are not always, the ray is not always going to be horizontal. I've literally seen students try to measure this angle like that. In order to measure an angle correctly, the bottom, the 0 degrees on the protractor has to be lined up with one of your rays. The 0 degrees has to be lined up. So, there we go. Oh my goodness, that is so much better. Now my 0 degrees is lined up with whichever ray I want. And I'm going to start at 0 and I'm going to start reading the numbers. I know it's hard for y'all to see. So 10, 20, 30, 40, 50, 60, all the way 110. I'm almost to 120. It kind of looks like 118-ish. I'm less than 120, but only by a couple tick marks. Good. Okay. So that's a reminder of how to use a protractor. Okay, if you have a protractor with you today, in your notes, we are going to draw angle YXZ such that the measure of angle YXZ is 53 degrees. So if you have a protractor today, use a straight edge or use a ruler or the bottom of your protractor and draw ray XY on your paper. So we have ray XY. Awesome. What does it say we do next? Use your protractor to place point Z at 50 degrees. So if we were told to draw our own angle, we would place with our protractor to where the vertex is on that little dashed line. And then we would read all the way 40, 50, and we would go 3 tick marks past the 50. 1, 2, 3, and we would put a little mark. There we go, I'll put it up here. Then we're done with our protractor. And then we get out our straight edge, or our ruler, and we draw, we call that Z. And we draw ray X, Z, and pretend like I have a straight edge. Woo, buddy, okay. So that's how you draw an angle given a measure. You probably already knew how to do that, but I'm pretending that we don't. Okay. Now we're going to do some constructions. We're going to do 2 constructions today. So do not leave class until we've done both of these, okay? All right, first I'm going to this website is called Math Open Reference. I'm going to send this out on Remind, but I want you to watch them construct a copy of an angle before we do, because they do it so nice and smoothly and pretty. Okay, first step, they drew a ray. Then they opened the compass, and they just made an arc. They go to their ray, and they make the same exact arc. Then they open the compass as wide as that arc hit, go to their ray, put the opposing arc, and connect the dots. Let's watch it one more time. So we draw a ray, which is already on your sheet. You open your compass however much you feel like. You intersect your angle twice, and you go draw that same arc on that ray. Then you open your compass touching J and K. You move down to your ray, you make the opposing arc mark, and connect the intersections. Okay, let me demonstrate it as well. That way you will have seen it 3 times. Okay, so your thing says to construct a copy of angle A. So what we're going to do first is open our compass however much we feel like it, put our needle on the vertex, make an arc, and then go to our ray and make the exact same arc. So far, I have made 2 arcs. They are identical, and it did not matter how much I opened my compass. Now, my arc hit the ray 2 times. 1, 2. In the online one, it was called JK. Now look, right now, my compass is not open to J and K. So I'm going to need to move my compass setting, because that setting was arbitrary. I need to move it to where the needle's on one point and the pencil's on the other. Once I've moved it, I'm going to come focus on this point down here. I'm going to be focusing right here. So, needle on one dot, pencil on the other dot. Now I move down here. I put my needle on that dot. Ooh, I almost didn't intersect. I draw what I call the opposing arc because it's going the other way. And then the last step, of course, is to connect the end point to that intersection right there. And I have made an identical twin to angle A. So the measure of this angle would be equal to the measure of this angle. Those angles would be congruent. Let's do one more. Angle B. Put my needle here. I'm going to make my compass a little smaller because this angle is kind of small. I'm going to construct an arc. I'm going to go down to where they want me to copy, and I'm going to construct the same exact arc. Cool. Matching arcs. Okay. Now I'm noting where the intersections are. I've got 2 points there. You don't have to put the points. I'm just doing that for emphasis. Right now, that compass setting will not work. We need the needle to be on one dot and the pencil to be on the other one. Oh, that's beautiful. See that? That's kind of measuring our angle, kind of, with reference. Now we come down here to this part right here. We put our needle on the intersection, and we make that opposing arc. That arc hits the arc we already drew. It intersects it at that point. And then I use my straight edge, and I connect the end point to the point created. And I have an angle. I'm going to use a double arc this time. I have a new angle that's the exact same measure as angle B. There we go. They match. I put double arcs to show that they match. So that is how we construct a copy of an angle. Now we're going to move on to bisecting an angle, and the lesson will be over, okay? Notice what number 3 asks to do. Number 3 says, construct the measure of angle C divided by 2. So that's asking to construct an angle bisector. That's what that symbol means, bisector. Okay? Step 1 looks kind of like step 1 last time. You're going to take your angle and you're going to make an arc. I'm going to go a little bit smaller. The arc is arbitrary. It does not matter how much you open your compass. So, it's blurry. My needle was on the vertex and I simply made an arc. That's step 1. Okay, this part's cool. I like this one better than copying an angle. Alright, you have 2 intersections, 2 points where your arc intersected the rays. So now, you're going to put your needle in both spots. You're going to put it here and then here. You're going to put it in A and then B. And watch what you're going to do. Put your needle on A and make an arc out here. Put your needle on B and make an arc out here. Those arcs kind of make an X, and where that X, where they intersect, is the point that lies on the angle bisector. So if I connect my vertex to that special point, oh my goodness, I have just cut that angle in half. This angle perfectly matches this angle. Arc, arc. Cool? Okay, I'm going to do it one more time, and I'm going to do it faster, so I'm not explaining myself as much. All right, angle D, let's bisect you. You're about to be bisected. Okay, angle D. Step 1, open your compass and make an initial arc. So needle on the vertex, take my compass, twist it, and make an arc. Put the needle on one intersection and make an arc out here. Put the needle on the other intersection and make an arc out here. Mine barely crossed, but you know what? They crossed. And that's all that matters. We're going to connect this dot to our vertex, and we will have the ray that divides this angle into 2 congruent angles. I'll use a double arc to show that they are congruent. Yay! Okay, so this lesson is over. You have a great homework assignment that really will show whether you understood what we did in class today or not. I will send out those links to the Math Open Reference website so you can watch it over and over and over if you need to.